Alrighty. Hello, everybody. Welcome to Education Part 2. We're starting right on time here today. My name is Jason. Last name's Howe. I'm talking about FreeBSD and how wonderful it is. So I want to poll the room real quick. How many people have interacted with FreeBSD or a variant in the past? What are our thoughts? Can I get like a thumbs up, a thumbs down on how we feel about it? All right, I'm seeing lots of thumbs down, maybe one iffy, a couple iffies. Alrighty, I'm gonna hopefully today you'll learn about it and keep your minds open and expand them to understand why FreeBSD is actually pretty cool and you can do some fun stuff with it. I have lots of fun facts. I think your minds will be blown by some of these fun facts that I learned this week. Case still met her hopes were high for this presentation, and that's my motivation to make a good presentation. So let's get into it. This is our agenda. We're going to talk about the history and the development of FreeBSD, going all the way back to 1967 and when Multics was made. We'll talk about how we use it, and you're gonna love that slide, I think. Then we're going to talk about some comparisons between FreeBSD and like most common Linux OSs. Talk about FreeBSD and pfSense, since a lot of people know what pfSense is because it's a common router that we use in competitions, and people they conflate the terms pfSense and FreeBSD. They're not quite the same, which makes it annoying for red teamers. And we'll talk about some fun things on FreeBSD. So welcome all. Hope you guys are taking notes. I just put a lot of my time this week in this presentation when I maybe should have been doing my capstone, but who cares? Alrighty. So this is me. I'm an old person here. This is my 5th year at RIT. Hopefully, when I focus on my capstone, I'll actually be able to graduate. I do red team. I did King of the Hill for ISTS. Had a great time doing that with some of my little buddies. I retired from black team, retired from CCDC. I'm pretty smart, I think, but I only got there because I did a lot of hard work. When I tell you that I came into college and I didn't know what Linux was, that is true. I opened up a terminal for the first time trying to do a CSEC 101 assignment, and it was crazy. I was like, cat, what's that? I got some back home. But then yeah, I learned me a lot of things. So here we are today, 5 years later, and I'm very, very different. Hope you guys enjoyed that picture, by the way. That is me during orientation. It was a great time. So there's some history of FreeBSD. We're gonna go all the way back to 1964, actually, when Multics was first being developed by some smart people, when computers were like just beginning to be like a thing. It was a project that some smart people were working on. Then some people named Ken Thompson and Dennis Ritchie, kind of like people who wrote and made C. Thank you. They left the Multics project with Bell Labs, and then they started working on Unix, which stands for the Uniplex Information and Computing Service, which kind of became like the Unix system that we know it is now. I mean, it's grown a lot in the past 50 years, but it's just kind of where it came from. Then soon into their development years, they realized that they wanted to make a lot of changes, and the start of all those changes needed a centralized language and like a good low-level processor. So they wrote C, and that's why we have C now. Then in 1974, the University of California at Berkeley, or UC Berkeley, got a license for Unix, which was now at the time in its version 4. And they started playing around with it, making a lot of changes. 1978, they released they were modifications of Unix, and they called it a BSD, which stands for Berkeley Software Distribution. So every time you see BSD, that's what it stands for. Then over the next 2 decades, they did a lot of development, a couple of lawsuits about copyright infringements with different companies and stuff like that. And eventually, they released Net 2, which was one of those things that had copyright problems with it. But they also released BSD 386, which was developed for the Intel 386, which was like a new and upcoming computer at the time. Then some developers that were working with the person who wrote the BSD 386 were like, this is getting really out of hand, trying to maintain this and keep it secure, all these patch files. What who's like, start fresh, with a new operating system that doesn't have any copyright problems, and it would be great. So they wrote FreeBSD, and then early 90s, 1993, they released FreeBSD 1. So that's how we got there. Is that what you guys came here for? The history of FreeBSD? Oh, great. So some purposes and how you can use FreeBSD when they over the development, the mission of the FreeBSD project. You can go read this on like their main documentation site. They're built on having a strong networking foundation. Their full, I guess their main file system structure is OpenZFS, whereas most things are not that. So that was fun to learn. Well, actually, I didn't learn it. I just used UFS instead. They have a lot of security features. They're very open source driven community. Lots of good documentation out there. They have a simple and consistent repository structure and build system. This actually plays out itself in a lot of unique ways, and that's one of the big differences between FreeBSD and Linux. They stay true to the Unix philosophy, and they got lots of binaries that you run on Linux can be run on BSD systems without a lot of modifications, which definitely has helped with the transition to BSD when people are coming from a Linux background. So that's like their philosophies over there. So here's some fun facts. The Netflix CDN is built on FreeBSD. So if you guys like streaming stuff, they've got 180 different countries, I think, now, and it's all built on FreeBSD. And remember the movie The Matrix from the late 90s? All special effects for The Matrix were made and rendered on FreeBSD. Mac OS and iOS at some point were started on FreeBSD or forks of it. It's since grown to be what they are now, but you see a lot of software similarities. And this is maybe only 25% true, but I heard a long time ago that a lot of the jailbreaks that you have for iOS are actually come from FreeBSD issues, big exploits and stuff. So that's kind of alludes to the similarity between them. And fun fact, both the OSs that were developed for the PS3 and PS4 were forked from FreeBSD. So any gamers out there probably use FreeBSD on the console. But aside from those fun facts, you can use FreeBSD for anything that you would use a regular Linux server for. So any services you want to host, like if DNS, HTTPS, an FTP server, an SMB server, whatever you want, you can do it on FreeBSD, which is pretty nifty. So how to use FreeBSD? The shell, the usual shell you'll get is CSH. Sometimes you'll get SH. You can install Bash if you want to. You can use TCSH. It's really up to you, whatever you decide that is best for your personal preferences. The package manager is PKG, and then you can go look at all the 30,000 different packages available for FreeBSD at ports.freebsd.org. We got a lot of cool stuff. Something I'll talk about later is the differences between PKG and apt or yum or DNF. Editors, they're all the same. You can get Vim for FreeBSD, you can get Nano, whatever you want to use, it's there. When I was making the demos, I used Vim because that's what I know how to use. Some people will complain that they don't have a good privilege escalation method. Usually the way you do it is you just use SU to switch users to whatever user you want. So you can just su root, and then there you go. Or you could PKG install sudo and set up a sudoers thing. You'd also use doas. These are all concepts that are the same from Linux to FreeBSD. Same with admin group. The wheel group is the admin group on FreeBSD, which is also the same as it is on RHEL systems. Ubuntu systems, the admin group is just sudo, but on RHEL and Fedora, all those kind of distributions, you have the wheel group. So yeah, are we still with me so far? As you can tell, it's very similar to Linux. just got different commands. They do the same stuff, different commands. All right, so here's some other commands that are exactly the same. You got ls, you got cd, you got pwd, you got cat, you got grep. Everything that you could use on a regular Linux distribution, you can use on FreeBSD because it is a Unix distribution. Just started a very long time ago. So some differences between FreeBSD and Linux. I liked this quote that I read, that BSD has been designed to work together, whereas Linux has been grown from different people, different ideas, different times. You could kind of take a Linux box and then dump whatever you want on it and make it work and still call it Linux. That's why there's about 1,000 or more different Linux distributions out there, whereas there's only a handful of BSD systems out there. So everything on BSD, I'll talk about this later as well, like the bare minimum stuff you need is called the base system, and that has been designed and reiterated on to make it work together as compact as possible. Whereas a lot of Linux distributions are just a conglomerate of different technologies. So you can take a different version of the kernel, you can take a different version of ls, you can take a different version of GNOME or KDE or whatever you want, and put it on there and make it work, and it's great for Linux. That's why Linux has got a lot of different stuff's going on. Whereas FreeBSD has been under centralized development for a long time. Some of the other starker differences or starker contrasts you could draw, PKG is not, so actually apt and yum, those generally install binary files. Like the file you're going to install when you install a deb, you're just going to drop files to different locations. You're not going to do any source compiling when you do the install. Whereas with PKG, you're usually building from source. So you copy down the source code, you build it, which means that you'll take care of any dependency issues. You'll take care of any other, when you're doing your compiling, you can set your pilot flags. If you have a tweak in your build, the customization that you get with PKG is a bit higher than what you would have with apt or yum or DNF, because you're building from source instead of just installing a precompiled file, which is actually one of the reasons why Linux fares a bit worse in long-term stability, because when you're installing precompiled packages, they all have their different dependencies, and then managing all those dependencies across your multiple projects becomes very much a problem. Whereas compiling from source, you take care of all those dependency issues at the start. Yeah, there's wheel and sudo. Yeah, you can install sudo on FreeBSD, which is real nice. And then, generally speaking, FreeBSD does not come with a desktop, so it's a terminal-based thing. You can install Xterm and other X applications if you want to, but I don't know, learn how to use the terminal and you'll be good to go. It's kind of like a Ubuntu server in that way, where you can install Ubuntu desktop if you want to, but it's right there. You just use the terminal. Everybody with me so far? Great. What have we learned? How are we feeling now about FreeBSD? We like it a bit more? No? Alrighty. I'll take another poll of thumbs up in some time. What do you think about the fun facts? I feel like those fun facts are kind of cool. Yeah? Alright, cool. I feel validated now. Thank you. Alright, so speaking about BSD and Linux distributions, I wrote down just about all of the BSD distributions on the left, my left, screen left. Yep. There's NetBSD, FreeBSD, OpenBSD, GiantFlyBSD. The differences between NetBSD and the rest of them is NetBSD is been designed, and the focus is to make it as widely distributed as possible, so you run on any computer anywhere. And they're largely succeeding with that. I don't have actual stats for it, but they get around NetBSD. OpenBSD is a security-focused BSD distribution, so they have a lot more restrictive things, and it's a lot harder to do nefarious things on OpenBSD, whereas FreeBSD is kind of designed to be pretty stable, be a good piece of software to use, be a good computer to use. And then DragonFlyBSD was a port of, a fork of FreeBSD, and it's kind of there. I don't remember what its special focus is on. And then the other thing that's interesting about FreeBSD is that you see all the times networking operating systems will be based off of FreeBSD. So pfSense is a fork of FreeBSD with their own modifications to it, and I think a lot of people who's used pfSense here. Yeah, a lot of people. Yeah. If you like pop into the command line, you'll see that it's like looks very much like FreeBSD because it's based off of it. OpenSense is very similar to pfSense, but it's based on OpenBSD. But it's also a router software. JunoOS, which is used for Juniper networking equipment, is based off of FreeBSD. TrueNAS, which is a like server software thing, something. I don't know too much about it. I'm probably getting this wrong. But it's also based off FreeBSD. And then we have all of our Linux distributions over here. So there's a lot of them. I think I have maybe 5% of the wiki list of Linux distributions that are on here. Does anybody not recognize one of these Linux distributions? Yeah, that's one of them. I don't have Nix. That is it. Yeah. Yeah. Pony and Nick. Well, not Nix. Pony and yeah, Temple, and then there was like what Tar OS. We're all kind of like similar. Oh, I forgot Temple.
Yeah, Temple.
Yeah. Yeah, I mean, I'm missing a lot because there's about 1 million of them. Fun fact, Red Star Linux is the North Korean version of Linux, and Red Flag is the Chinese equivalent of Linux. Yeah. BIOS is Debian-based routing software, so if you really don't like pfSense or OpenSense or whatever, you can use BIOS if you want to. Just don't ask Zach for help because he has bad memories of CCTC practices. And yeah. So yeah, pfSense and FreeBSD, they're not the same thing, which I've learned over a couple of years of red teaming. First and foremost, pfSense is a firewall, and it's only supposed to be a firewall, which means that when we go to red team it, we have to introduce new capabilities to what it's designed to do. There's no compiler on FreeBSD because they don't want you installing softwares on it that they don't like verify themselves. Which pfSense is distributed by Netgate. They're like a company. They have different pfSense products. There's the community edition. They sell actual hardware boxes, and they have the plus edition of pfSense. Anyways, one of the fun things about FreeBSD is they have their servers to network managers called inetd, which also available on Linux, but pfSense got rid of that, which made me very sad. They're also missing a lot of header files, so in case you try to like file something on FreeBSD on the right version and then copy it over to pfSense, probably missing header files, which sucks. They redid the whole RC system, which we'll talk about later, and the documentation of how everything works and what they've changed is not great. So pfSense, kind of annoying, in my opinion. But yeah, so let's talk about some fun things on FreeBSD. I'm going to start with the RC system, which is, I guess you'd call the equivalent to systemd or systemd init or whatever like service manager kind of boot system you have on like your normal, I guess like more well-trafficked Linux distributions. So RC is the boot system and the overall controller for BSD. In the beginning of the development for FreeBSD, it was just one monolithic RC file, and it was etc.rc, and that controlled everything from startup to customized system services, and it was like a multi-thousand line file. And so if you wanted to change anything, you had to go figure out where it was, what's changed, and all that good stuff. And that was fine. But if you wanted to say stop the service to restart it because something didn't work, you need to make a modification, there wasn't an easy way to do that. You had to go into etc.rc, find the process, you had to kill the process, you had to go wait for it to exit successfully or not. Then you have to go back into etc.rc, find the commands that were used to start it with all the extraneous flags, and run those commands on the terminal to restart it. And that's how you would restart a process with the initial, like with RC back in the day. But wait, you might ask, what happens if I have something that has multiple daemons or multiple things that is like running, such as a lamp stack or another large piece of technology that has multiple services that make it run? Well, that's pretty tough to do with the RC service file. So after they realized some of the limitations of that, they started developing semi-modular RC scripts, but this led to more confusion because you weren't sure, like they didn't really define like the process for when the RC script would be loaded. They made one called like RC.network, but that was waiting on like RC.file system, and there were other things that were just making it too confusing. So then they made something called RC.D. There's actually a nice paper, 11-page white paper on it. If you guys want to go read that, I think I linked it in the recommended reading at the end of the slides if you're interested. So yeah, they made RC.D, which simplifies the whole system. It was made by a guy named Luke Mewborn, and it started with FreeBSD, but then it was integrated into FreeBSD around like V6, I believe. So the focuses of RC.D were to have code reuse and find modularity, so that you could add a service here, take away a service there, but you would like specify your order for everything, and everything would be fine and dandy. So the main components of this, there's etc.rc, which is your startup script. There's etc.rc.shutdown, which is your opposite of RC, just handles the shutdown and got the graceful exiting. And then there's the config file, rc.conf, which you can use to configure things about the RC system. And then because they want to focus on code reuse, they made a library called rc.subr, and this has a lot of helpful functions to handle just different things for other RC scripts. So there's functions to like load the config file, there's functions to run the program, functions to restart things, and lots of wonderful things. And then to keep things organized, and maybe you've seen this convention in other areas, like if you set up an Apache site, you can have like your sites.enable.d, and then you can put like your subpages in there. Very similar thing with etc.rc.d. You can put your specific RC scripts in that subdirectory, and that will be the place where you can have your fine modularity. So yeah, RC is pretty nifty. Are we still with me? Great. Are we feeling good about FreeBSD now? All right. I've got Jack. I've got Jack from a negative to a mid. I'll take it. And then there's this fun little tool called RC Order you can run to see what the order of the RC scripts are. So when you've got a large system and you're trying to like understand what's coming up when, you can run that to figure out the whole list and make a tree like thing, and it looks pretty cool. So here's an example straight from the man pages. So the numbers correlate to the description on the left and the right. So the first thing we got is our shebang bin sh. All our RC scripts are written in sh, otherwise under shell, and they must be shell compliant. So we just start with that. Then if we want to use the RC subr library, we just have to like source it in our script, which we do with the dot and then the etc subr number 2. Number 3, we have to name our script, so we specify the name. In this example, we just call it dummy. Then we can use the name variable throughout our script to keep things simple and also reusable. So if I have, say, a config file for a custom program, but I want to write something similar to it, I just copy the RC script that I made for the first thing, turn it into the second thing without having to change all these static variables. Very similar to the concept of global variables in coding. Actually, it's the same concept. So 4, we can specify either like the one command to use for start, stop, and restart, or we can specify start commands, stop commands, and restart commands. On this example, they're using start and stop. So we define what we want to do on start, which is call the function dummy start. Then we define what we want to do on end, which is nothing. Then we define our function, dummy start, and right now, this is just a little example, it's just gonna echo out nothing started. Then at the end, we load the RC config, and like the config with our name as a variable, and then we run it, and it works because it's simple. And it's great. So that's a little dummy example. Everybody with me? So swag. So here's an example for FTP. So at the top you see we have our shebang, and then we have some comments about what we need to do before, like what we need before it. We require that the login and the file system RC scripts are ran and like working before we can do ours. And then we give our name, we give it a description, we give it the command, we give it the name of the pip file we want to run, or like have associated with this script. Then it's not much, but then we kind of fish out. We find a function just to like what to do before we start, which we define our RC flags as just like little flags you want to run, little flags you want to run with RC. That's not a very useful definition, but it's kind of like compiler flags when you're like using Clang or GCC, whatever. And then yeah, we got our name. We do a run at the bottom, and there we go, FTP. Cool. Next fun topic with FreeBSD jails. Everybody knows what a container is, like on Docker. Everybody know what chroot is, or chroot, however you want to say it. Everybody not familiar? All right, cool. Anyways, BSD jails are very similar to those. They are isolated environments on FreeBSD systems where you're gonna have independent users, independent processes, independent networking, and independent file systems. It's supposed to be a security concept, and it actually works out pretty nifty. So it's similar to change root, but better. With change root, you only limit the file systems. You're not limited on the users, the processes, the memory, the networking. They were first introduced in FreeBSD 4, and there's two types that we're going to talk about today: the thick and thin jails. So yeah, that's like the little graphic. I thought it was kind of fun. All right, so we got change root. A little background on that. So what you can do with change root is just limit the root, quote unquote, directory for a process or a command. So you often see this with FTP. When you have users log into an FTP server, their root directory in the FTP server will be not the actual root on the box, but say it's like home/FTP or whatever root you've defined for in the FTP config file. This keeps things from having like remote file inclusion issues. So, but as I said, it does not really restrict memory, processes, users, or networking. There's all stuff that jails do. So if you have some exploitable thing in those other areas, not just the file system, change root's not going to protect you from that. So, and in my reading up for this presentation, they did talk about how there's a number of change root escapes. I don't have any listed for you, or I don't really know what they were talking about, but I know that they're out there. So that's interesting. So talk about thick jails now. To make a thick jail is a complete copy of FreeBSD file system. It'll run its own like FreeBSD instance inside of your running FreeBSD instance. This gives you lots of degrees of isolation, gives you lots of independence, and gives you some rest, and you can rest soundly knowing that you'll be very secure. The cons is that it is resource intensive and it's high maintenance. Because it's its own copy of the file system, you have to keep it updated, keep it patched. Fun fact, you can't have a higher FreeBSD version in the jail than what you're currently running on your system. So if I was running like 13.2, I couldn't install 14 in the jail. I have to install something less than 13.2. So yeah, that's a thick jail. A thin jail is also a jail, but more of the file system is replicated. It's similar to change root. It'll be faster to deploy and more resource efficient, and you'll have easier maintenance because you're having copies of the file system that you're currently using in the jail. So instead of having to maintain 2 systems or as many systems that you have in jails, you only have to maintain the one. You kind of duplicate file system resources over, and it's a bit smaller. The problem with that is that you have reduced isolation since the file systems are mounted to each other. You also have just decreased security. So in a thin jail, if I changed a file, that file would also be changed on my actual host, which is similar to mounting a Docker container on like the root directory and then editing its password. Not great. But then because you're also mounting things, you could have dependency issues if you try to install one version of the software in a thin jail and then another version of software somewhere else. You're using the same root file system, so you could have dependency issues. You guys with me to jail so far? Cool. So to prepare your system for creating jails, first you need to enable jails on the system using sysrc. Then you need to actually make the infrastructure for the jails. You use makedir, or if you're running like an open ZFS file system, you would use the appropriate commands for that. Since we're not doing that, we just got makedir, and we make user local jails, and then the media templates and containers. And then we have one config file, either etc jail.conf, or you can use the subdirectory approach with etc jail.conf.d with all your sub jail config files being something.conf. So that's pretty cool. So here's an example of a jail. We're going to go through it piece by piece because I couldn't fit the picture in detail and the descriptions of what everything was on the same slide. But this is also straight from the man pages, so you feel free to go read up in there if you want to at the same time. But I think, who's looked at like a systemd server file before? I see like some similarities to our jail service file. Well, I guess our jail config file and sysb service files. Anybody see any similarities? I want to like shout them out. This is what we call crowd work, guys. You gotta like work with me too. All right, Sherrod, what you got? Anything? Sherrod's not paying attention. Casey, what you got?
It's similar to
Sherrod said exec start.
yeah, and then like computing victims and tax.
Mm-hmm.
I think that this is fun. The thing is, there's some of these different and then we can do it, but it's pretty much.
Yeah, true. Alrighty. So yeah, let's get into it. So first things first, up at the top. Can I move the caption somewhere? So
Yeah.
how do I do that? Alright, cool. I don't want to like mess it up.
You want them like just up here?
Yeah,
Okay.
that works.
Yeah.
Great.
Cool.
Alright, cool. So yeah, first things first, you gotta name your thing. So the jail name here is the name of the jail. So you can call it whatever you want. You call it Alcatraz, something silly. Then you define what you want to do when you start and stop the jail with your exec start and exec stop. And you define where you want to write your logs to for the jail. Oh, I should have cleared that with demo. That would have been good to know. I'll do that before I publish it. Then steps 5, 6, and 7. You define the permissions for the jail. Allow raw sockets will allow you to run ping and traceroute and other networking utilities like that. Exec clean will make sure that you're running all your commands in a clean environment. And then your mount.devfs will just mount the dev file system in the /dev directory of the jail. So I'm not too sure what the last two things mean. They're just on the man page, so I figured I'd put them in here. Then number 8 and 9, you specify the host name, which we're just going to reuse the name variable from the top, which was our jail name. And then we define where like the host, I guess like where like the root path of the jail is gonna be. So here we put user local jails containers, and we use our name variables again, and that's steps 8 and 9. So everything's kind of relative to that path. So everything you install in the jail, like your etc directory, your bin directory, you can actually access from the main host if you go through that entire path, which is pretty cool. And some fun stuff can happen with that. That's all I'll say. Number 10, 11, and 12, specify the IP address. You specify IPv6 if you want to, and then interface to use for the jail. Usually this is the same as the host interface. These two are not like mutually exclusive. They're not both required. You have one, you have the other. If you want to be able to access it, I recommend having at least one. So yeah, that's our sample with jail config file. Then to manage your jails, you can run JLS to see you're running jails. Very similar output to Docker PS if you ever ran that. Then very similar to like systemctl or just regular service. And do your jail stop, starts, and restarts. You just do service jail, your action, then the jail name that you want to run it on. Then if you want to remove a jail, you will have to stop it. You do a change flags command. I don't really know what that does. It's just in the man page. I'm assuming it removes things or sets all the flags to 0 so you can actually delete them. And then you just run your rm-tacrf to where your jail is. And then, yes.
What happens if you try to remove a jail without stopping it?
I have no idea. I didn't test that. I'm assuming that it doesn't work. Probably. Or like action not allowed. Yeah. I guess my guess is that they set some immutable bit. That's why you need to run the change flags. But I didn't look into that part too much. But that's my best guess here. Then to install packages or do things in the jails, it's kind of like Docker exec. If you have used Docker in the past, you can run pkg with stack jflag for the jail. Then the name of the jail will come after it. So in this example, we call the jail classic. Then you do like you install whatever package you want. To access the jail, you can do jexec, which will pop you into a shell in the jail if you have permission to do so. Normally, jexec is a root only command, so problematic if you want to pop it, if you want to get into a jail as a non-root user, or if you just want to run a command in the jail one-off instead of actually getting a shell, you can do jexec tac I for the jail name, and then your command after that. Everybody still with me? Swag. So this is my last fun topic, and it's called base system separation. So FreeBSD is built around what we call the base system, and it's the minimum amount of software that it needs to run. It's similar to like the minimal install for Linux distributions, but instead of you install getting a bunch of like dev or RPM packages and installing those, everything you actually need is already built into the base system. Everything in BSD is like purpose built and designed to work together. So I kind of talked about this earlier, where you take whatever kernel you want with Linux and slap on some LS and slap on KDE, and put Apache on there and do whatever mumbo jumbo you want. It's kind of like making a stew, I guess. Just like throw some ingredients in the pot, stir it up, comes out right. I guess FreeBSD in this food analogy is kind of more like baking a cake. You can't just like throw a tomato at the cake and then have a cake with a tomato on it. It's not gonna work, you know. Everything needs to actually be like purposely measured out and put together. You gotta put your flour in there. You gotta put your baking soda and your sugar and your eggs and your water, whatever else you need for the cake. You gotta put that in there, mix it up right. So yeah, the base system. Because of this design, you'll actually see very commonly that only like the top level directories like boot bin, sbin, user etc, like all of those are only touched in the base system, and that any packages you install and any like user modifications you're supposed to make are supposed to happen in the user local, then directory name after that set of directories. So when you install sudo, You want to go like modify the etc like the sudoers config file instead of going to etc sudoers, which you would do on regular Linux. You actually have to go to user local etc sudoers, which is interesting. But this actually helps with their dependency problems. And since you're not modifying the top level directories when you install some tool, if tool X only needs like version Y of some software, then tool Z needs version Y.2 of that same software. Because they're all installed in the like user local directories, you can handle those dependency issues very easily. The boot kernel directory has the kernel and all associated modules. So if you're a blue teamer looking for FreeBSD kernel modules, that's where you gotta go look. I'll give you another hint. There's not a lot of kernel modules for FreeBSD. And then if you run the which command, which does what? Anybody? Or you run like what? Yes. It'll search the base system first and then third-party packages later. And so a fun red team tactic, I guess, is like path exploitation. So with on regular Linux, you have like user, you got bin, you have user bin, you have user local bin. Determining on the search pattern for binaries, you can put a shimmed version of a binary somewhere in that path so that yours get called first, and you can modify the input, the output, whatever you want about the command. So say my binary is supposed to be located at like user local bin normal ls, but then I put my malicious version of that at user bin like malicious ls, and then my malicious ls, I call the normal ls, I grep out some output that I don't want the blue teamers to see, such as like the name of my tool, some other strings, and I return that. That's called shimming. Also maybe sometimes called like not really functional hooking, but I guess like execution flow hijacking is like the appropriate term for all of it. On FreeBSD, what I just described, they make it hard to do because they'll search the base system first and then third-party packages. So say I put my thing in user local bin red team malware and I try to like hijack ls, it's not going to work out because they'll search the base system first and then third packages later. So you have to get more creative. So yeah, that's base system separation. That's like one of the bigger, probably one of the biggest differences between Linux and FreeBSD is how they designed like the base system and like the bare minimum that you need. So that's all I got about this. Questions? Yes. More stable installs, less dependency issues. So if you're trying to run a system for a longer period of time, over time you're gonna have less problems. Great documentation out there where they actually explain like what and why versus most of the time you just get what in the man page. And obviously lots of professional companies have seen value in FreeBSD. So if you think Netflix is doing something silly, why'd they pick FreeBSD? No, that's because they're greedy. That's different. Because apparently you're not family, don't live in the same household. Other questions? I got another 5 minutes up here. Surely you all understood all of that.